What's up, everybody? Welcome back to another live stream from Scalar Learning. And today we are continuing with Khan Academy SAT math problems, straight from the source, straight from Khan Academy. And today we are tackling, what is it? Data inferences. So let me just take a look, make sure we are good to go. Academy. And let's rock it. All right, here we go. All right, question 1 of 5. In the National Health and Nutrition Examination Survey, 80.5% of the participants had healthy levels of high-density lipoprotein. The estimate has a margin of error of 1.5% at a confidence level of 95%. Okay, first of all, my margin of error is already, we want to be familiar with this term margin of error. So we're saying 80.5%, but the margin of error 1.5% means that it could be as high as this plus 1.5%, which is 82%, right? That's just 80.5 plus 1.5, or minus 1.5, which goes as low as 79%. So I'm going to already put my range of this 80.5% healthy levels value in between that zone, 79 to 82, all right? The participants were a random sample of United States residents. If the U.S. population at the time of the study was 316 million, what is the estimate at a 95% confidence level? This is almost, we don't even need to worry about this. They're both the same. Level of the number of people in the U.S. who had healthy levels of HDL cholesterol. Okay, so again, now we're not talking about 80.5% of this 316. We need to calculate this range. We need to calculate 79% of that number, all the way up to 82% of that number. This is a calculator problem, so let's go ahead and pull up the calculator. So how do we calculate 70, oops, there we go. How do we calculate 79% of 316? Remember, we don't need to enter millions because the answer, if you take a quick glance, is in the millions. So how do we do that? We turn it into a decimal and make it 0.79 times 316 is 249.64. I will round up to 250 because it looks like there's no decimals. So we got 250 million at the bottom, and then 82% of 316.82 times 316 is 259.12 or 259. So there's my range. It's between 250 to 259, and there we go. Should be C. All right, excellent. Let's move on to question number 2. After randomly sampling 1,000 cars, a car wash determined with a 95% confidence that the mean time needed to wash a car is 8 minutes and 56 seconds. So again, I'm not really, oh, well, this actually changes the confidence level. But anyways, determined a 95 confidence level that a mean time needed to wash a car is 8 minutes and 56 seconds with a margin of error of 7 seconds. So my margin of error is 7 seconds. So here we go. The mean time is 8:56. So that means the mean could be as high as this plus 7 seconds, which is 9:03. Use your calculator if you're not sure about that. Or subtracting 7 seconds, which is 8:49, right? 7 seconds off. So this is where my mean value is lying somewhere in that range. Which of the following could be the bounds of a 90% confidence interval based on the same sample? All right, here's the deal. 95% confidence means I'm pretty sure I'm going to capture this. So it's like with a greater percentage, with a greater confidence level, this should be wider. With a smaller confidence level, 90%, now we should be in a tighter zone. So let's say it could be like, I don't know, 8.52 to 9.01 or something like that. So the range should be shrinking because we're less confident, okay? The tighter we get, the less confident we get. So anyways, I'm guessing that there's only going to be one that's going to be a tighter range. This is not a tighter range. This moves up, but that pops up to 9:05. It should be shifting down, right? 8 minutes and 40 seconds to 9 minutes. Again, this drops while this also drops, but it looks like that range is bigger, so I doubt that's it. If we're talking about a tighter confidence level, this zone in between should be shrinking. Let's see, 8 minutes and 40 seconds to 9 minutes and 5. Definitely not this. 8 minutes and 50 seconds. This makes sense. Okay, because what's happened is, forget about the 852. I made that number up, right? But at least we're getting a slight rise here and a drop here, right? So the bottom line is it's a tighter zone. It's only 10 seconds instead of 14-second spread, right? This is a 25-second spread. This is a 20-second spread, right, from 8:40 to 9. And this is a 15-second spread, so just barely above 14. This is only one where it drops. Let's see if that makes sense. And there we go. All right. Next. An archaeologist uses an accelerator mass spectrometer, which don't even get bogged down in what that is. It doesn't matter, to find the age of a buried branch. At 68% confidence level, the spectrometer estimates that the branch was 10,000 years old with a margin of error of 200 years. So we're talking about a margin from 9,800, where I subtract that 200, up to 10,200. Okay, and this is at 68% confidence. Which of the following could estimate the branch at a 95%? So now again, we're massively increasing the confidence level, which means that we should have a much wider range. Okay, so 9,800 to 10,200. I'm thinking it should be like 8,500 to, I don't know, 11,000, something like that. We're making it, because look, the bigger we make it, yeah, it's maybe less accurate, but the greater confidence we can have that the correct value is within this pocket, right? If we go from negative infinity to positive infinity, if we stretch it that way, we have 100% confidence that we've captured the mean. It just doesn't tell us that much. But anyways, or calculate in this case, just the estimated age. So let's see, we got 9,500 with a margin of error of 500. That could work, actually. Hold on. See, because that would be 10,000, 9,000 down to 10,000. So it's a bigger range of 1,000. But the problem is now we're clipping that 10,200. We're going below it. I don't know about that. I don't like that one. 10,000 going up 400, down 400. This one's all right. Right, it's the exact same value, but now we're increasing the margin of error to 400, from 200 to 400. So I like B. This one is way tighter, and it's changing the estimate. I don't like that. And it's way, way, way tighter. It's only a range of 100, right? 50 up, 50 down, 95, 50, 94, 50. And this one doesn't make sense. This is tighter too, right? Same. I'm immediately discounting 9,500 because why is that shifting? Why is the estimate shifting? But we should have the same estimate with a bigger margin. So I'm liking B, and there we go. All right. Right, just as a reminder, I'm solving these in real time. I haven't seen these before, so I'm solving them on the spot. So I'm actually really legitimately going through the reasoning process live with you guys. All right, next. Random sample of 500 residents of town included 173 residents who primarily spoke a language other than English at home, with a margin of error of 25 and a confidence level of 98. So 173. So we're talking a margin of error of 25. So we're going as high as 198, right, plus 25. As low as 153, 148. This is calculator, so you can use the calculator if you want. And that looks right, a range of 50. Okay, then if the town has 25,000 residents, how many residents primarily speak a language with the same confidence level? So again, we're talking about this, right? This is out of 500. So we're going to calculate the equivalent. So 148 out of 500 at the top value, and 198, at the bottom value, 198 out of 500 at the top value. Whatever these amount to as percentages, actually decimals is better in this case, we take the same decimal or percent equivalence of the 25,000. So watch, this will be pretty straightforward. 148 divided by 500, 0.296, right? 0.296. And this is really 29.6%, but we don't need to convert it to the percentage. And then 198, I can do this mentally. This is 39.6. Oops, 0.396, sorry. 0.396. Let's double check. 198. There we go. Okay, now I multiply these by the big number, by the actual value, 0.296 times 25,000. Let's do this one first. Oops, 0.396 times 25. So we already know our upper bound is 9,900. Let's see, anything that doesn't have 9900 can be taken out. It's got to be this one. But then let's just calculate it just for fun. 0.296. Make sure I read this right. Hold on. Yeah. Times 25 is 7400. Boom. So I'm sticking with A, and it is good. All right, next, last but not least, in the national health, whatever. This looks like actually the first one. Sometimes I have seen them do this where they repeat. It looks literally identical to the first one. And I think this was the answer, right? Let's just double check anyways. So it had healthy and a margin of error of 1.5%. So we're talking at the high end, 82%. At the low end, 79%. If the U.S. population is 316 million, what is the estimate with the same confidence level? Whatever. So we do 0.79 times 316. So just look back at how I did number one, because I think they messed up, and it's the exact same. 249, right? So we round up to 250. And then 82%. 316 is 259. And that's what I think, selected this guy. So just if you want the full explanation, just look back at how I did number one. Same problem. All right, there we go. That is it, my friends. That is it. So thank you guys so much for checking this out. I hope you enjoyed it. I hope you appreciated it. If you did like it, please click the like button. And if you have any questions or comments or want to see more from the Scalar Learning channel on this, just leave a comment in the comment section. I'll be glad to get back to you as soon as I possibly can. Thank you guys so much for joining, and I'll see you all in the next video. Take it easy.